guys, today we're going to be talking about how to calculate energy, wavelength, and frequency. So it's going to be a lot of math, so get ready and saddle up to a world of fun. I know it's not the best to be learning virtually, but yet here we are. And I'm talking on Zoom by myself because I couldn't figure out how else to do this. First of all, there are three characteristics for waves. So we have wave speed, we have frequency, and we have wavelength, and they all have a mathematical relationship. So we can use this particular formula, B equals wavelength times frequency, to be able to calculate any of those. Now B, it looks like velocity, but it's going to stand for the actual wave speed. And usually wave speed, not usually, but wave speed is going to be 3 times 10 to the 8 meters per second. And this is always going to be the same. Okay, so this is the speed of light. So we already have B. This is called lambda, and this is going to represent wavelength, and this thing right here is frequency. So the example, what is the wavelength of a wave of light if it has a frequency of 3.2 times 10 to the 14th? So the first thing I'm going to do, what I like to do, is just to write down everything that I already know from the problem. So I know that the speed of light is going to be 3 times 10 to the 8th. That the frequency is going to be 3.2 times 10 to the 14th. Just pretend that's a 10. This is a 10. And what I'm trying to find is wavelength. So wavelength is what? I don't know what wavelength is. So one thing I like to do like a little triangle to be able to see this relationship better. This. Okay, so we have wave speed, we have wavelength, and we have frequency, and this is my confused face. I don't know what the heck is going on. So I am trying to find wavelength, so I'm going to put my confused face right there. So that means that I'm going to divide wave speed by frequency, and that's how I'm going to get my answer. So that's how you're going to rearrange the whole equation. So we said that my thing was going to be wavelength is equal to wave speed divided by frequency. Divided by frequency, and frequency is going to be 3.2 times 10 to the 14. Okay, now this whole thing looks like a very scary number to me. Honestly, like, that is just ridiculous. I cannot do it. Oh my god, so scary. So what I'm going to do, instead, I'm just going to be lazy and figure out another way to do it. So let me show you the way I do it, because I am just a scaredy cat. So I'm going to get these numbers first, and I'm going to divide those first. Okay? So first thing, 3 divided by 3.2. And that's going to be 0.93.75. Next up, I am going to copy the times 10. So I'm just going to put times 10. And the next thing, I am going to subtract these two numbers. So the reason I'm subtracting is because I am dividing the numbers. So when you're dividing exponents, you're actually just subtracting. So this is going to be 8 minus 14 is going to equal -6. This number right here, this exponent, is just going to tell you how many times you should move the decimal point. The negative sign tells you you should move it to the left side. So that way you're going to get the actual number. So if you move this little dot to the left 6 times, you're going to get the actual number. If it was positive, it would be to the right hand side. Now, if you just want to make it prettier and you want to move this to the right hand side, that means that it would take a lot more to be able to get there, right? To the left hand side that it wants to go. So if I want to put this number, 75 times 10. Both of these numbers are the exact same number. Like, they're the exact same thing. They just have the decimal points in a different place, but they are the exact same number. So either of those answers is correct. So let's do problem 2. It says find the frequency of a 4.00 times 10 to the negative 11 wavelength of the violet light. So we are still using the same particular formula, which is this one right here. So I need to rearrange it. So I need to find the frequency. So I'm going to put my confused face over here, and it's going to be wave speed divided by wavelength. So it's going to be wave speed by wavelength to be able to find frequency. So my wave speed, 3 times 10 to the 8 over wavelength, which is 4. So just like we did last time, first thing I'm going to do is to divide this 2. So 3 divided by 4 is 0.75. And then I am going to copy the times 10. And then I am going to subtract both of these. Now notice the sign. So it's 8 minus negative 11. So 8 minus negative 11. So that's going to be 19. Again, if you want to move the decimal point to the side, so it would be 7.5. The only difference is that there is less road to take to get to the actual number, so it would be 18. Same exact thing. Sometimes you're going to see examples like this. Like example number 1. What is the energy of violet light with a frequency of 7.5 times 10 to the 14th s minus 1? So that means like cycles per second. You're going to be using Planck's equation, which is E equals h times f. E equals h times f. So the only thing here is h. H is always going to equal the exact same thing. So it's going to be h equals 6.63 or 626, depending, times 10 to the negative 34. It's always going to equal that. Always. So energy is going to equal 6.63 times 10 to the negative 34. So if they're asking you how much energy does it need, or how much energy is it, then all you have to do is multiply this times the frequency that they gave you, which is 7.50 times 10 to the 14th. So in true light of my personality that I don't want to do much, all I'm going to do is multiply this times this. So this is 6.63 times 7.5, and that's going to equal 49.72. And then I'm just going to copy the times 10. And since I am multiplying, I'm going to add the exponents. So this is negative 34 plus 14, and this is going to be negative 20. And there's your answer. Again, if you want to move the decimal point this way, then this would change to negative 19. Okay, and problem number 2. Find the energy of light if the wavelength is 4.06 times 10 to the negative 11. So they are asking us to get energy using this equation, but they are giving us wavelength. So wavelength is nowhere here. So the very first thing that we have to do is actually find frequency. So they are trying to find frequency, so wave speed divided by wavelength. What we are going to do is, why did I make that sound? Wave speed divided by wavelength. And wave speed, like I said, is the speed of light to the infinity and beyond. So speed of light divided by wavelength, which is 4.06 times 10 to the negative 11. That is equal to 3 divided by 4.06. That is 0.73 or 74, 0.74. And then I'm going to add the times 10, and then I'm going to subtract this 2. So 8 minus negative 11 is going to be 19. This is going to be the frequency. Okay, so we are not done. We still have to multiply times Planck's constant, which is 6.626 or 6.6 sits 3 times 10 to the negative 34. So I am going to multiply my frequency times 6.63 times 10 to the negative 34. So I'm going to multiply these two numbers, so 0.74 times 6.63, and that's going to give me 4.9. I'm going to copy the times 10, and then I'm going to add these two numbers. So 19 plus negative 34 is going to be negative 15. And this is my answer. Oof, that was too much. That's it! Thank you guys for watching. This was the weirdest thing I had ever done. I'm like alone in a Zoom meeting trying to do this because I couldn't draw anywhere else. So for more math, I'll figure it out next time. Thank you for watching. See you later. Bye.